American wire gauge, right? And so if you start using a different number, you're not talking about American.
Maybe that's why they never used it.
I don't know. No, they did use it. All right, so now, assuming that it's what the table shows, we can make some assumptions, right? We can find out what the length is, and if it's more than 1,000, we know something's screwy. It's got to be less than 1,000. And then someone would go out in the back and take this all out and measure it with their measuring device. Right? Who's going to do that?
A measuring device.
Like a yardstick. Or what about your calculus students? Alan, can you do this? Where you like calculate the diameter of this wire here and then how many times it wrapped around, and you can figure out how long it is using calculus. I know there's a way.
We just get like a meter and...
Well, we did this. I'm just saying we need to have some confirmation of what this is. Now, if it works out to be more than 1,000, we're screwed, right? So we're assuming it's aluminum. We don't know the length. And the cross-sectional area for 24 gauge, that's that 400.4, right? Yeah, 404, like the area code. So we're running out of phone numbers on. All right, and so if we solve for the length would be 13.2 multiplied by 404 divided by 17. What is that number? I need a calculator. Oh, I have a calculator. Where are you going, Brandon?
Oh, nowhere.
Nowhere. On my documents, in my desktop, I have my funky TI emulator calculator. You taking a video?
Yeah, make it easier.
Okay. Post the video if it's any good. 313 feet? Okay. So someone, 313 exactly?
0.69.
Okay, 0.7. Remember when you take that quiz, if the answer is 313.7 feet, you're going to answer 313.7, no FT. We don't want that FT. That way you can get the right answer if it's right. That's not the right answer. Can't tell you anything about it. So 313.7 feet is what this is saying. Now it might have been used because it might have been wound up all the way to the edge. It really might have been. I have no idea. It's been in the tech shop for like 5 years. The only way to know for sure other than doing this is to pull out your measuring device and measure it in the outside. Or I think there's a way. I know there's, out of all these people, one of these calculus nerds is here. Isn't there a way when you wrap this around tightly, you can measure the diameter of the fire type, and then you can figure it out somehow?
Well, I don't think it'd be calculus. I mean, you could do something like a series.
Oh, so it's not calculus?
I mean, I'm not saying that for sure, but it seems similar to like, I used to do like a whole bunch of stupid math problems where like there's a stadium and then the seats are this wide and it increases by this many seats each
time. So you can come up with some technique to find out how much is in here. Now actually, you might come up with another, does anyone have one right now? If you don't have one right now, it's okay. Post it later, or when you come back Tuesday, you say, I thought of a way to figure out how long this is, a different way, and we want to compare it to this number and see how close they are. Right? Now I know one way is you unwind it and measure it. Well, yeah, they're doing the same thing we're doing. Yeah, calculate. That's the same thing we're doing. That's not exciting. So, and there might be some device where you can say, this reel can be dispensed into another reel, and while it's doing it, it measures how many feet it is, right? Or maybe you create just a simple mechanism so that you could do that. And then I think it is calculus because the radius changes as the wire gets taken off, and so it's a DR, right? It changes, and that's why I was thinking calculus. Who knows? All right, so now we have time. We can do different temperatures. We have time, right? And so what's the temperature in the box? It's still negative 15. We have to do this very carefully. How are we going to do this? We have got to attach one of the wires to this. We did talk about the problem of putting this in that oven over there, right? We can't melt the wires. That would be a problem with the reading as well as make the tech shop mad. All right, so I carefully put it on there. Is it reading 13.2 right now?
It's off.
Oh, it went to sleep. I hope no one in here went to sleep. I saw one a little while ago. Yeah, it says 13.2. Now, what is it? It says that it's negative 15. Now, it's maybe going to warm up when I open the door. So we'll carefully put you inside. Did I lose the 13.2? I told you it's going to be difficult because my wire is too short. How about that? Is it still on there?
Yeah.
It went off.
Bent. ice around. Now the other thing, that's buried. Which one is it? Is that one? That is buried in the ice, but I need to put it outside of the ice so it's actually in the air. We don't want the temperature of the ice. All right, carefully put this on here. And we'll actually have to let it sit for a while for it to really settle. I've never done this before. The evening class hasn't done it yet either. Can anybody get this on there, stay? If you just had your Leatherman. I don't have it. Actually, I do. How
Maybe
come-
you should break this plastic off.
Yeah, but I'm worried I'll get people mad at me.
It's just plastic.
Well, they have just blame it on someone else.
Oh, they have used it. They've used 700 feet of it. All right, is it measuring something? All right, yeah. So carefully.
Hold the wire.
Don't slam it all the way shut.
Well, I need to make sure it stays cool in there.
Oh.
Spit. All right, well, we're not going to slam it all the way shut this time. All right, we'll just do that. All right, the temperature in there is 17 degrees 17 degrees Celsius? Or, that's not cold. I mean, it's cold, but it's not much colder than 20. All right, while it's doing that, we'll get this heater up. Wasn't it negative earlier? But it was in the ice.
Yeah, it's in there.
This is not in the ice. So plug this in because mine, you got to, yeah, plug that in, Sebastian. 13.2 still. All right, we'll put this on keep warm. All right, so now, well, that was an epic fail. But it still demonstrates something. The resistance hasn't changed, but the temperature is still like 19. I would think it would be at least closer to 0. But this thing right here, sitting right here, so we need like a sub-zero refrigerator. That shows 18. But it might take a while for it to get cold. All right, so how's this doing? Are we warming up? Yeah, we're warming up. So let's put a probe in there. What's the maximum temperature we found we can put that at? Huh? I thought it was 190. Is that right? That's what we think we said. Someone verify that on the interwebs. All right, so we still got a reading. Okay, good. All right, over here, let's carefully put this wire in here. Now this will get hotter faster, right? Hopefully. If it gets too hot, we'll burn up some wire.
Yay.
Oh, don't touch anything in there. Oh, excellent. It's on the metal. Okay, it's heating up. 30 degrees already. 31, 32. It would be nice if it's on Fahrenheit because we don't have to do the conversion in our heads like Alan was talking about. It's 98. 99. Can you see this?
Yeah.
I don't want it touching that metal, so I'm going to go ahead and bend it up a little bit. I don't care. This belongs to me and it hadn't been used in 3 years. Is it in the air? Oh, spit it. It's close to the element. Maybe if we put it like there, it's in the air. All right, now what is it? 165. Turn this down. 178, 181. Turn this down. Woo! Woo! Let's go down. Down. Ooh.
209,
Back
211.
down. Now let's release a little heat. Are we going down yet? Are we stabilizing? I mean, the
still
200 is
going up.
right here. Okay. Is it still in the air? We want it in the air because we don't want the temperature of metal. We want. Oh, it's stabilizing. It's going down. Whew, yeah. It's going down. But we don't want it to go down too much. But we also don't want it at 223. But remember, just like the bridge that can handle 10 tons, even though it's rated for 8, we might put it in there at 218 or something. And if the wire melts, it melts. All right, so what if I close it now? What does it stay at? Let me know if it goes up. How are we doing over here? 13.1. It went down. What does that mean? The temperature might have gone down because it was 13.2. Now you would expect qualitatively, right? And when you have experiments, sometimes you have quantitative results and sometimes you have qualitative. Qualitatively, you do expect it to go down when it gets colder. and go up when it gets hotter. But again, how cold are we? Let's see. I can quickly swap this and find out how cold it is in there. That says it's negative. I got to put it on temperature. That says it's negative 15.9. Oh, that because that is not sitting in the air, right? That wire's sitting in the ice where it's cold. But anyway, we're getting a resistance reading of now. Oh, I got to put it on resistance. Don't see. I can forget too. That's why you have to remind the people in the procedure. Oh, now it's 13.2, but I probably opened. Okay, now what are we
Now
at?
it's back down to 13.
209. I think we're ready. All right, let's do it. Here we go. We should expect a larger variation when we've got like 200 degrees Fahrenheit, right? We'll find out. But it does need to sit in there for a little while. How much time we got? 2 minutes remaining. Oh, spit. This is going to be quite challenging. That wire, see how it stays on so nicely? So if this doesn't work, it's because
How do you plan on getting it out?
I don't know yet. I don't know yet. I'm just going to put it in here. All right, is it let me know if it's reading a resistance once I get it on there. Oh, spit. We need a Leatherman to pull that wire out. I'll bring my calipers. I can't get that thing on there. Let's see. You got an alligator clip? Oh.
Oh.
I got it on there.
We'll bring a lot of our tools next time.
Oh, now the black one come off. Always come to prepared. Hey, it's $1.99. Perfect. All right, now what we'll do, we'll definitely see a qualitative result. I don't think we're going to be able to see a quantitative result today. Does this bore you?
Can you get a nice multimeter for less than $200?
Spit. Spit. Can you? Yes, you can get a nice multimeter for $19. Is it reading something? Oh, holy catfish! It's reading and it's in there. Okay, hold on. Put that in there. All right, put that in there. Put that in there. Close it gently without burning yourself. It doesn't really close gently. Okay. That temperature's wrong. Maybe. I don't know. Well, it is hot. And it is, everything's connected.
I don't think it's on.
Is it off? Crank it up.
Red light on it.
Well, I see the thermocouple, but it's touching something that was in the freezer. So let me pull it out. Oh, don't do that. Ooh, don't do that. Okay, there you go.
20,
There it goes up. Okay, let me know if it gets too hot.
30, 40.
I haven't seen any qualitative changes to the resistance yet. This burns.
Maybe the rubber's insulating the temperature too
Oh,
much.
this burns. Stop that. Oh, stop.
Going to 180. 190.
Okay, 190. Have we seen any? We haven't seen a change yet. That burns. Oh, let's crank this sucker up. This burns, man. Hold this. Yeah, there we go. Still, no qualitative increase.
It's going down. Okay.
Yes, because it's... Oh, it's going up! It's going up! 13.3. 180. Crank it up. I don't want to go up too high. We don't want to melt the plastic. 250. Ow, that hurts. What? 215? Oh, you looked it up?
No, I'm just saying our safety.
Was that in the air? It's in the air. Oh, now I don't have to touch it. Everything's controlled. Okay, good. Here you go. Why is it at 1.8? Let's turn it up. It's probably because something cold was went in there and it's kind of dispersing the heat.
Yeah.
This is a thermodynamics problem, too, for you thermo people. Hey, we're still at a solid 13.3. So qualitatively, we've certainly illustrated it. But we've got to be... There's 200. And I don't want to go up much higher. I don't want to melt the plastic. Hey, 13.4. We went up to 13.4. Exciting, huh? Let's not melt the wire. Woo! Is that wire melted? It's hot. Set it over there. All right, next time we'll have more material.